Welcome to Tech with Kaushik. This is part 5 of our complete practice question series for the AZ-305 Microsoft Certified Solutions Architect Expert exam. Choose your answer before the timer ends. Then review the correct answer, explanation, and exam tip. Let us begin part 5. The next key item is question number 183. This one tests your understanding of storage performance. The central scenario is as follows. A SQL Server VM uses separate premium SSD data disks for transaction logs and database data files. The design must preserve write ordering for logs while improving read performance for data files. Match each disk role to the recommended host cache mode. The first set contains Item 1 on the left, transaction log disk database data disk. The right side choices are right option A, none. Right option B, read only. Right option C, read write. The correct pairings are left item 1, transaction log disk, pairs with none. Left item 2, database data disk, pairs with read only. The reasoning is as follows. Log disks should use no host caching to preserve durable sequential writes. Data disks can use read-only caching to accelerate reads without caching database writes. Remember this distinction for the exam. Use no cache for SQL log disks and read-only cache for data disks unless workload testing or storage architecture dictates otherwise. Proceed to question number 184. An on-premises Oracle database feeds an Azure Analytics platform. Azure Databricks will transform the extracted data before it is loaded into Azure Synapse Analytics. The design needs an Azure landing store and a managed orchestration service that can reach Oracle. Which two services should be included? Select 2. More than one answer may be correct. Option A, Azure Data Lake Storage Generation 2. Option B, Azure Data Factory. Option C, Azure Import Export. Option D, Azure Data Box Gateway. Option E, Azure Data Box Edge. Select Option A, Azure Data Lake Storage Generation 2, and Option B, Azure Data Factory. The key reason is Data Factory can connect to on-premises Oracle through a self-hosted integration runtime and orchestrate ingestion. ADLS Generation 2 provides the scalable lake storage Databricks can access for transformation. The other choices do not satisfy the requirement because C, Import Export is an offline disk transfer service, not recurring pipeline orchestration. D, Data Box Gateway is a virtual storage gateway and is not required for this database ingestion design. E, Data Box Edge adds edge compute and transfer hardware not justified by the requirements. Keep this examination point in mind. For recurring on-premises database ingestion, pair Data Factory orchestration with ADLS Generation 2 as the analytical landing zone. Question number 185. This question moves us into event-driven design. Scenario. An order API publishes an event containing a vendor code. The integration layer must route each event to the matching Azure function endpoint without polling and must support filtering by event type. The solution does not require ordered command processing. Which integration resource should be used? Review the options. Choice A, Azure Event Hubs Capture. Choice B, an Azure Data Factory Pipeline. Choice C, an Azure Service Bus Queue. Choice D, an Azure Event Grid Topic. In this case, select option D, an Azure Event Grid Topic. Event Grid provides push-based event routing and subscription filters that can direct different event types to the appropriate Azure function endpoint without requiring the consumer to poll. The alternatives can be eliminated because A, Event Hubs Capture writes event streams to storage and does not route business events to functions by type. B, Data Factory is batch and data integration orchestration, not low-latency event routing. C, a single queue provides competing consumer command delivery and does not independently fan out or filter to multiple handlers. A useful examination rule is this. Use Event Grid for reactive event routing and Service Bus for durable commands requiring enterprise messaging semantics. We will now analyze question number 186. Review the scenario carefully. A key backed up from an Azure Key Vault in West US must be restored to another vault. The subscription must remain unchanged. Where can the backup be restored? Compare the following options. Option A is only to the original key vault. Option B is to any vault in the same Azure geography and subscription. Option C is to a vault in any Azure geography. Option D is only to a vault in the original region. The appropriate choice is option B, to any vault in the same Azure geography and subscription. This is correct because a key vault object backup can be restored to another vault when both vaults are in the same Azure subscription and Azure geography. The remaining options are incorrect because A, restoration is not restricted to the source vault. C, cross-geography restore is not supported. D, another region in the same geography is permitted. The key takeaway is key vault backup portability is bounded by both subscription and Azure geography. Let us focus on question number 187. We are moving to Azure Front Door. This scenario establishes the key requirement. A web application runs in several Azure regions. The proposed access layer is Azure Front Door with WAF rate limit rules, multiple healthy origins, and health probes. For each statement, select yes if the statement is true. Otherwise, select no. Review Statement 1. The proposal can rate limit clients, distribute requests across regional origins, and fail away from an unhealthy region. The answer to Statement 1 is yes. Front Door provides global Layer 7 load balancing and health-based failover, while its WAF supports rate limit custom rules. Front Door is the global HTTPS entry point when both application layer routing and WAF rate limiting are required. Let us work through question number 188. Begin by examining the scenario. A content archive stores large images, video, and audio as objects. It needs at least 500 requests per second, does not require single-digit millisecond premium latency, and must minimize storage cost. Which account type should be provisioned? Choose from the following options. Choice A, premium file shares. Choice B, premium page blobs. Choice C, standard general purpose v2. Choice D, premium block blobs. The best answer is option C, standard general purpose v2. Here is the technical justification. Standard GPv2 supports high-scale block blob workloads and large media objects at a lower cost than premium object storage when premium latency is not required. The incorrect choices fail for the following reasons. A. Premium files provides SMB/NFS file shares rather than economical object storage. B. Page blobs are optimized for random read/write disks such as VHDs. D. Premium block blobs can meet the workload but adds cost for latency and transaction performance that are not required. Exam tip. Choose standard GPv2 for general object storage. Use premium block blobs only when latency and transaction consistency justify the premium. The next item is question number 189. Next, we enter the topic of disaster recovery. Review the situation. A company is replatforming SQL Server databases to a managed Azure service. Administrators must retain native user-initiated backup capability, and the service must provide Microsoft-managed replication and failover between two Azure regions with minimal operational effort. Complete the database continuity design. The first statement reads, use the blank as the database deployment. Select from Azure SQL Managed Instance, Azure SQL Database Single Database, or SQL Server on Azure Virtual Machines. The second statement reads, use the blank for cross-region resiliency. Select from a failover group, zone redundancy only, or manual backup copy. Statement 1 should be completed with Azure SQL Managed Instance. Managed Instance preserves broad SQL Server compatibility, including native backup scenarios, while remaining PaaS. Statement 2 should be completed with a failover group. A failover group manages geo-replication, listener endpoints, and failover across regions. Remember this distinction for the exam. Use failover groups for managed regional failover, zone redundancy addresses only, and availability zone failure. Let us examine question number 190. Consider the following scenario. An Azure SQL logical server is reachable through a private endpoint in VNet Hub. The VNet uses a DNS forwarder VM and is connected to an on-premises network by ExpressRoute. A private DNS zone containing the private endpoint record is linked to VNet Hub. Complete the conditional forwarding design for on-premises name resolution. For the first statement, configure the DNS forwarder VM to send queries for the private zone to the blank. Choose between Azure-provided DNS at 168.63.129.16, the public DNS zone, or the SQL public endpoint. For the second statement, configure the on-premises DNS servers to forward the private zone suffix to the blank. Choose between the DNS forwarder VM in VNet Hub, Azure-provided DNS at 168.63.129.16 directly, or the public DNS zone. The correct value for Statement 1 is Azure-provided DNS at 168.63.129.16. A DNS forwarder in the VNet can query Azure-provided DNS and resolve records from private DNS zones linked to that VNet. The correct value for Statement 2 is the DNS forwarder VM in VNet Hub. On-premises DNS cannot query Azure-provided DNS directly, so it forwards the private suffix to the reachable Azure DNS forwarder. Keep this examination point in mind. Azure DNS Private Resolver can replace DNS forwarder virtual machines in newer designs and reduce administration. Now consider question number 191. Consider this scenario. A single transactional database must continue through an availability zone failure and use synchronous replicas so committed data is not lost. The design should avoid paying for managed instance features that the application does not use. Which deployment should be selected? The options are: Choice A, Azure SQL Database Serverless without zone redundancy. Choice B, Azure SQL Managed Instance General Purpose. Choice C, Azure SQL Managed Instance Business Critical. Choice D, Azure SQL Database Business Critical with zone redundancy. The required response is option D, Azure SQL Database Business Critical with zone redundancy. The requirement is satisfied because Business Critical Azure SQL Database provides synchronous replicas and supports zone redundant placement, meeting the requirement at database scope. Now consider why the remaining options are unsuitable. A. Serverless general purpose does not provide the required synchronous zone redundant architecture. B. Managed instance general purpose does not meet the stated replica requirement. C. Managed instance business critical adds instance scope and costs that are unnecessary for one database. A useful examination rule is this: when instance-level compatibility is unnecessary, prefer database-scoped business critical for synchronous zone resilience. Review question number 192. Carefully. The focus now shifts to global routing. Let us first review the situation. A web app has active instances in several regions. The proposed access service is Azure Traffic Manager. The design must enforce per-client rate limits, distribute requests, and survive a regional outage. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. Azure Traffic Manager alone satisfies all three requirements. Statement 1 should be marked no. Traffic Manager provides DNS-based traffic distribution and endpoint failover, but does not inspect HTTP requests or enforce application layer rate limits. The key takeaway is Traffic Manager is DNS routing. Use front door or API management when request level rate limiting is required. Apply precise reasoning to question number 193. Pay close attention to every stated constraint. A web app has instances in multiple Azure regions. The proposed access service is a standard regional Azure load balancer. The design must rate limit HTTP requests, distribute traffic globally, and fail over between regions. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is, the proposed Azure load balancer design satisfies all requirements. For the first statement, choose no. Azure Load Balancer is a Layer 4 service and a regional deployment does not provide HTTP rate limiting or the required global application routing. Use front door for global HTTPS distribution. Load balancer handles regional TCP/UDP flows. Proceed to question number 194. An Azure function exposes a public endpoint that lets customers retrieve order status. The endpoint must not accept operations that create or modify data, and callers do not receive function keys. Complete the HTTP trigger design. Review statement 1. Allow the blank as the HTTP methods. The options for this statement are get only, get and post, or get, post, and delete. Review statement 2. Set the trigger authorization level to the blank. The options for this statement are anonymous, function, or admin. The answer to the first statement is get only. Get is the read-only HTTP method required by the API. The answer to the second statement is anonymous. Anonymous permits public calls without a function or host key. Other security controls can still be applied at an API gateway. Exam tip. For production public AP is, place an authenticated gateway in front when anonymous direct function access is not acceptable. Now consider question number 195. The focus now shifts to VPN design. Scenario. An on-premises network uses 172.16.0.0/16. An Azure VNet uses non-overlapping 192.168.0.0/16 address space and will host 30 virtual machines plus a site-to-site VPN gateway. The VM subnet must have more than 30 usable Azure addresses, and the gateway requires its own /27 subnet. Match the prefixes to the required Azure subnets. Begin with the following source items. Source item 1, 168.0.0/24. Source item 2, 168.1.0/27. The destination requirements are as follows. Target A, workload subnet for the 30 virtual machines. Target B, gateway subnet. Map 168.0.0/24 to workload subnet for the 30 virtual machines. Map 168.1.0/27 to gateway subnet. The reasoning is as follows. The /24 provides enough usable addresses after Azure reservations and does not overlap the on-premises range. The separate /27 is suitable for gateway subnet and also remains non-overlapping. Remember this distinction for the exam. Azure and on-premises prefixes must not overlap, and gateway subnet must be dedicated to the VPN gateway. Question number 196. Review the situation. A data engineering team must visually design a mapping data flow that transforms files from blob storage and writes the results to Azure Data Lake Storage Generation 2. Which service provides mapping data flows? Available choices. Option A, Azure Data Box Gateway. Option B, Azure Data Factory. Option C, Azure File Sync. Option D, Azure Databricks only. The correct answer is option B, Azure Data Factory. The key reason is mapping data flow is a native Azure Data Factory capability for code-free, Spark-based transformations within pipelines. A, Databox Gateway is a storage transfer appliance. C, File Sync caches Azure file shares on Windows servers. D, Databricks can transform data, but is not the service feature named mapping data flow. Keep this examination point in mind. When the requirement explicitly states mapping data flow, select Azure Data Factory or Synapse Pipelines. The next item is question number 197. Take extra care here because this is a hard question. Consider this scenario. An AKS cluster has a Windows node pool and a horizontal pod autoscaler is already configured for a Windows container workload. During demand spikes, pods remain pending when the node pool has insufficient capacity. New Windows nodes must be added and removed automatically. Which scaling feature should be enabled? Review the options. Option A, virtual nodes with Azure container instances. Option B, the AKS cluster autoscaler. Option C, a newer Kubernetes API version only. Option D, another horizontal pod autoscaler. The appropriate choice is option B. The AKS Cluster Autoscaler. The Cluster Autoscaler increases or decreases the Windows node pool size when pods cannot be scheduled or nodes are underused. The other choices do not satisfy the requirement because A. Virtual nodes do not provide the required Windows node pool scaling design. C. Changing the Kubernetes version does not scale compute capacity. D. HPA changes pod replicas but cannot add VM nodes when the cluster lacks capacity. A useful examination rule is this. HPA scales pods. Cluster Autoscaler scales AKS nodes. Many production workloads use both. We will now analyze question number 198. Let us first review the situation. A new Azure Data Factory instance must copy 500 gigabytes from an on-premises Windows file server into Azure storage over the network. Complete the ingestion setup. Statement 1. On a machine that can reach the file server, install the blank. The available choices are a self-hosted integration runtime, the Azure File Sync Agent, or File Server Resource Manager. Statement 2. In the Data Factory, create the blank to define and run the copy activity. The available choices are a pipeline, an import-export job, or an Azure SSJS integration runtime. For Statement 1, select a self-hosted integration runtime. The self-hosted integration runtime provides the network bridge from Data Factory to the on-premises file system. For Statement 2, select a pipeline. A pipeline contains the linked services, datasets, and copy activity that moves the files. The key takeaway is the source was a visual hotspot and did not state where the runtime should be installed. It must run on a supported host with access to the source. Proceed to question number 199. Review the situation. A company is retaining 100 existing SSJS packages while moving their destination databases to Azure SQL Database. The packages must run as managed Azure workloads with minimal redesign. Which Azure service should host and execute the SSJS packages? Choice A, SQL Server Migration Assistant. Choice B, Azure Data Factory with an Azure SSJS integration runtime. Choice C, Data Migration Assistant. Choice D, Microsoft Purview Data Catalog. In this case, select option B, Azure Data Factory with an Azure SSJS integration runtime. This is correct because Azure Data Factory can provision Azure SSJS integration runtime to lift and shift, deploy, and execute existing SSJS packages that connect to Azure SQL Database. The alternatives can be eliminated because A. SSMA converts database schemas and code for heterogeneous migrations. It does not host SSJS execution. C. DMA assesses and assists SQL Server database migration but does not run SSJS packages. D. Purview catalogs and governs data assets rather than executing integration packages. Use Azure SSIR to run existing SSJS packages. Use native Data Factory pipelines when redesigning the integration workflow. The next item is question number 200. Scenario. A Windows Server VM contains local files that an Azure Data Factory pipeline must read, transform, and load into Azure Data Lake Storage Generation 2. Which component must be deployed where the files are reachable? The options are: Option A, the Azure Pipelines Agent. Option B, the self-hosted integration runtime. Option C, the Azure File Sync Agent. Option D, the on-premises data gateway. The best answer is option B, the self-hosted integration runtime. Here is the technical justification. Self-hosted integration runtime enables Data Factory to connect to private network or local file system sources and move data to Azure services. The remaining options are incorrect because A. The pipeline's agent runs CI/CD jobs. C. File sync synchronizes Windows file servers with Azure files. D. The on-premises data gateway is used by services such as Power BI and Logic apps, not as the Data Factory file connector runtime. Exam tip. For Data Factory access to private or local sources, deploy a self-hosted integration runtime near the source. Next, question number 201. A visual effects studio runs Azure batch pools with eligible RHEL subscriptions. Development tests are short, restartable, and interruption tolerant. Production MPI simulations run for many hours, and must complete by a fixed deadline. The studio wants to use its Linux subscriptions and minimize compute cost. Complete each recommendation by selecting the pool allocation mode and node type. Review Statement 1. For interruption-tolerant development jobs, use the blank. The options for this statement are user subscription pool with low-priority virtual machines, batch service pool with dedicated virtual machines, or user subscription pool with dedicated virtual machines. Review Statement 2. For deadline-sensitive production MPI jobs, use the blank. The options for this statement are batch service pool with dedicated virtual machines, user subscription pool with low-priority virtual machines, or user subscription pool with dedicated virtual machines. Statement 1 should be completed with user subscription pool with low-priority virtual machines. Low-priority capacity is economical but can be reclaimed. Statement 2 should be completed with user subscription pool with dedicated virtual machines. Dedicated capacity is appropriate when predictable completion is required. Remember this distinction for the exam. Use interruptible batch capacity only when tasks can checkpoint, retry, or restart without violating deadlines. Let us work through question number 202. Consider the following scenario. A single Azure App Service app must retrieve a partner API secret and connection strings from Azure Key Vault. The identity should follow the app lifecycle. No credentials may be stored in code, and authorization must use Azure or BAC. Complete the identity and authorization design. The first statement reads, authenticate the app to Key Vault by using the blank. Select from a system-assigned managed identity, a user-assigned managed identity, or a client certificate stored in the app. The second statement reads, authorize secret retrieval by using the blank. Select from a Key Vault Secrets user role assignment, a private endpoint, or a connected service. The correct value for Statement 1 is a system-assigned managed identity. The identity is bound to the app and requires no credential rotation. The correct value for Statement 2 is a Key Vault Secrets user role assignment. A private endpoint controls network reachability but does not grant secret permissions. Keep this examination point in mind. Separate authentication, authorization, and network isolation when designing Key Vault access. Review question number 203. Carefully. This question moves us into serverless architecture. Review the scenario carefully. A retail platform needs to run a PowerShell cleanup task every night. The task completes in less than 5 minutes, has no user interface, and should incur no charge while idle. Which compute option should host the scheduled maintenance task? Review each available choice. Choice A, Azure Logic Apps. Choice B, Azure Functions with a timer trigger. Choice C, an Azure Virtual Machine. Choice D, an App Service Web Job. The required response is option B, Azure Functions with a timer trigger. The requirement is satisfied because a timer-triggered Azure function runs short-scheduled code without maintaining a server and uses consumption-based billing. The incorrect choices fail for the following reasons. A. Logic Apps is better for connector-driven workflows than a small code-centric script. C. AVM creates continuous management and compute cost. D. A web job requires an app service plan, which is unnecessary when no plan already exists. A useful examination rule is this. For short-scheduled code with idle periods, prefer a timer-triggered function over continuously provisioned compute. Question number 204. Requires careful analysis. Analyze the scenario before evaluating the choices. An AKS cluster runs bursty Linux container workloads. New workloads must start without waiting for additional VM nodes, and the platform team does not want to operate another node pool. Which AKS scaling capability should you recommend? Compare every choice before deciding. Consider option A, horizontal pod autoscaler. Consider option B, cluster autoscaler. Consider option C, the AKS virtual nodes add-on. Consider option D, a manually installed virtual kubelet deployment. The correct answer is option C, the AKS virtual nodes add-on. The reasoning is as follows. The virtual nodes add-on schedules eligible pods to Azure container instances, providing rapid burst capacity without provisioning or managing additional VM nodes. Now consider why the remaining options are unsuitable. A. HPA changes pod counts, but still requires available cluster node capacity. B. Cluster autoscaler provisions VM nodes, and therefore has longer scale-out latency. D. The managed AKS add-on minimizes effort compared with a manually maintained virtual kubelet deployment. The key takeaway is HPA scales pods, cluster autoscaler scales VM nodes, and virtual nodes provide rapid serverless burst capacity. Now consider question number 205. A manufacturer must relocate one Azure VM to another Azure region and migrate one VMware VM from its data center into Azure. Match each workload movement to the Azure service designed for that operation. The source items are as follows. Source 1. Relocate an existing Azure virtual machine to another Azure region. Source 2. Migrate an on-premises VMware virtual machine to Azure. The target positions are Destination Option A, Azure Migrate. Destination Option B, Azure Resource Mover. Destination Option C, Azure Arc. The first mapping connects relocate an existing Azure virtual machine to another Azure region to Azure Resource Mover. The second mapping connects migrate an on-premises VMware virtual machine to Azure Migrate. The key reason is Azure Resource Mover coordinates supported cross-region Azure Resource Moves. Azure Migrate discovers, assesses, replicates, and migrates on-premises servers to Azure. Use Azure Migrate for data center to Azure migration and Resource Mover for supported Azure to Azure regional moves. Let us examine question number 206. Next, we enter the topic of Azure Front Door. Begin by examining the scenario. A public app service application is deployed in 3 Azure regions. The entry service must fail over across regions, enforce WAF policies, keep a user on the same healthy origin when needed, and route /API and /media paths to different origin groups. Which service should provide the global application entry point? Now examine the possible answers. Option A is Azure Front Door Standard or Premium. Option B is Azure Traffic Manager. Option C is Azure Application Gateway. Option D is Azure Load Balancer. The appropriate choice is Option A, Azure Front Door Standard or Premium. Azure Front Door is a global Layer 7 service that supports origin health-based failover, WAF, session affinity, and path-based routing. B. Traffic Manager is DNS-based and does not provide WAF, cookie affinity, or HTTP path routing. C. Application Gateway is regional and cannot by itself provide global multi-region failover. D. Load Balancer operates at Layer 4 and lacks WAF and URL routing. Exam tip. Choose Front Door for global HTTP routing and Edge WAF. Choose Application Gateway for regional Layer 7 routing. Question number 207. Consider this scenario. A logistics company needs a stateful microservices platform that can run in Azure and in its own data centers. Services must be upgraded independently, support very low latency communication, and use health policies to repair failed service instances automatically. Which platform should the architect recommend? Available choices. Choice A, Azure Container Instances. Choice B, Azure Logic Apps. Choice C, Azure Service Fabric. Choice D, Azure Virtual Machine Scale Sets. The correct answer is Option C, Azure Service Fabric. This is correct because Service Fabric supports microservices, independent application upgrades, health evaluation, and automatic repair patterns in both Azure-hosted and standalone clusters. The other choices do not satisfy the requirement because A. Container Instances does not provide a full hybrid microservices orchestrator with upgrade and repair policies. B. Logic Apps is a workflow service, not a low-latency microservices runtime. D. VM Scale Sets scale virtual machines, but do not supply microservice lifecycle and health management semantics. Remember this distinction for the exam. Select an orchestrator based on service lifecycle, state, health, and hybrid hosting requirements, not only VM scaling. Now consider question number 208. Consider this scenario. Telemetry files arrive continuously in Azure Blob Storage. A reporting team needs a managed pipeline that incrementally copies and transforms new files into Azure SQL database. Which service should implement the recurring data movement? Available choices. Choice A, Azure Data Factory. Choice B, Data Migration Assistant. Choice C, Azure Data Box. Choice D, Azure Database Migration Service. In this case, select option A, Azure Data Factory. Here is the technical justification. Azure Data Factory provides scheduled and event-driven pipelines with blob storage and Azure SQL connectors for recurring ingestion and transformation. The alternatives can be eliminated because B, DMA assesses compatibility and is not a recurring ETL service. C, Databox is for offline bulk transfer. D, Database Migration Service handles database migrations rather than continuous file ingestion. Keep this examination point in mind. Use Data Factory or Synapse pipelines for repeatable data integration. Use migration tools for finite migrations. The next item is question number 209. Review the situation. A globally distributed mission-critical application requires a managed data platform with contractual service levels for provision throughput and low-latency reads and writes. Which data service best meets the requirement? Review the options. Option A, Azure Data Lake Storage Generation 2. Option B, Azure Blob Storage. Option C, Azure SQL Database. Option D, Azure Cosmos DB. The best answer is option D, Azure Cosmos DB. The requirement is satisfied because Azure Cosmos DB provides service-level commitments covering throughput and latency for supported configurations, in addition to availability and consistency guarantees. The remaining options are incorrect because A, data lake storage is optimized for scalable analytics storage, not database latency and throughput SLAs. B, blob storage is object storage rather than a low-latency transactional database. C, Azure SQL provides database availability commitments, but not the same globally distributed throughput and latency SLA model. A useful examination rule is this. When a question explicitly requires database latency and throughput SLAs, evaluate Cosmos DB first. Proceed to question number 210. We are moving to semi-structured data. Scenario. A small SaaS system stores 20 unrelated key-value datasets. Clients use the table REST API. Data must be copied automatically to a secondary region for disaster recovery, but the application does not need to read the secondary copy during normal operations. Cost is the primary concern. Which storage design should you recommend? Option A, Azure SQL Elastic Pools with active georeplication. Option B, Azure Table Storage in an account configured for GRS. Option C, Azure Table Storage in an account configured for RAGRS. Option D, separate Azure SQL databases with active georeplication. The required response is option B, Azure Table Storage in an account configured for GRS. The reasoning is as follows. Table storage provides a low-cost REST-accessible NoSQL table service, and GRS asynchronously replicates the account to a secondary region without the added read access cost. The incorrect choices fail for the following reasons. A. SQL Elastic Pools add relational database cost and complexity not required by key-value tables. C. RAGRS adds secondary read access that the scenario does not require. D. Separate geo-replicated SQL databases are more expensive and operationally complex. The key takeaway is choose GRS when only regional durability is required. Choose RAGRS when applications must read the secondary endpoint. Question number 211. A multi-tenant survey service has a browser-facing web app and a protected web API. Signed-in users delegate permission to the web app, which calls the API with OAuth 2.0 bearer access tokens. Complete the delegated authorization design. Statement 1. The bearer access tokens are issued by the blank. The available choices are Microsoft Azure ID, the front-end web app, or the protected web API. Statement 2. Authorization for an API operation is enforced by the blank. The available choices are Microsoft Azure ID, the front-end web app, or the protected web API? The answer to the first statement is Microsoft Intra ID. The identity provider issues tokens for the requested resource. The answer to the second statement is the protected web API. The resource server is responsible for enforcing access to its operations. The authorization server issues tokens. The resource API validates them and enforces permissions. Review question number 212 carefully. This is a harder question, so check every requirement carefully. Review the scenario carefully. An engineering company must run tightly coupled 3D geometry calculations across many compute nodes. The workload uses MPI-style communication, must scale to many nodes, and should require minimal scheduler and cluster management code. Which two design actions should you recommend? You need to identify two correct options. Now examine the possible answers. Option A is build and maintain a custom VM-based render farm. Option B is run the workload on Azure Batch. Option C is use a single shared Azure file share as the scaling mechanism. Option D is enable internode communication for the batch pool. Option E is orchestrate each calculation with Azure Logic Apps. The choices that satisfy the requirement are Option B, run the workload on Azure Batch, and Option D, enable internode communication for the batch pool. The key reason is Azure Batch manages pool provisioning, scheduling, and scaling. Enabling internode communication allows tightly coupled tasks on the pool to exchange data directly. Now consider why the remaining options are unsuitable. A custom VM farm increases implementation and operations effort. C. Shared storage does not enable MPI communication or manage compute scaling. E. Logic Apps is not a high-performance parallel compute scheduler. Exam tip. For tightly coupled HPC on batch, verify VM family, node placement, and internode communication requirements. Question number 213. Scenario. AKS clusters run in 4 Azure regions. Container images must be pushed once and automatically replicated close to every cluster. Which registry design should you recommend? Choices. Option A, geo-redundant Azure storage accounts. Option B, Azure Container Registry Premium with geo-replication. Option C, Azure Content Delivery Network. Option D, Azure Cache for RedISS. In this case, select Option B, Azure Container Registry Premium with geo-replication. The premium tier of Azure Container Registry supports geo-replication, so one registry can maintain regional replicas near distributed AKS clusters. A. Storage account replication does not provide a container registry or image lifecycle operations. C. CDN caches web content and is not a private image registry. D. RedISS is an application cache, not an OCI image store. Remember this distinction for the exam. Use AC or premium georeplication for multi-region image distribution to AKS. Let us work through question number 214. Next, we enter the topic of authorization design. Consider the following scenario. An organization uses Azure Cosmos DB for NoSQL and wants selected Microsoft Intra users to query documents without distributing account keys. Which authorization approach should you recommend? Choose from the following options. Choice A. Assign the Cosmos DB built-in data reader data plane role to the users. Choice B. Issue shared access signatures and apply conditional access. Choice C. Store account keys in Key Vault and email them to approved users. Choice D. Assign the Azure Resource Manager reader role at the subscription scope. The appropriate choice is Option A. Assign the Cosmos DB built-in data reader data plane role to the users. This is correct because Azure Cosmos DB for NoSQL supports native data plane, or BAC, with Microsoft Intra identities. The built-in data reader role grants query and read permissions without exposing keys. The other choices do not satisfy the requirement because B. Cosmos DB for NoSQL does not use storage-style SAS for this access model. C. Shared account keys provide broad access and are not identity-specific. D. The control plane reader role does not grant document data access. Keep this examination point in mind. Cosmos DB control plane Azure RBAC and native data plane RBAC are separate permission systems. We will now analyze question number 215. Let us first review the situation. A research platform requires petabyte-scale blob storage, nested directories, and POSIX-style access control lists at directory and file level. Which Azure storage configuration should you recommend? Compare the following options. Choice A, a premium blob account without hierarchical namespace. Choice B, a general-purpose V2 account with hierarchical namespace enabled. Choice C, a premium page blob account. Choice D, a premium Azure Files account with large file shares. The correct answer is option B, a general-purpose V2 account with hierarchical namespace enabled. Here is the technical justification. Enabling hierarchical namespace on a GPv2 account creates Azure Data Lake Storage Generation 2 semantics, including directories and POSIX ACLs on blob data. The alternatives can be eliminated because A, without hierarchical namespace, the account lacks native directory ACL semantics. C, page blobs are optimized for random access disks and do not provide the required hierarchy. D, Azure Files provides file shares rather than the required blob storage model. A useful examination rule is this. Hierarchical namespace is the decisive feature for ADLS Generation 2 directories and ACLs. Question number 216. Now, this question moves us into database scalability. Scenario. A company owns eligible SQL Server licenses with software assurance. It will host 50 Azure SQL databases whose utilization peaks at different times. The design should share compute across databases and apply Azure Hybrid benefit. Complete the purchasing and deployment design. For the first statement, use the blank purchasing model. Choose between DTU, vCore, or Azure Reserved VM instances. For the second statement, deploy the databases in the blank. Choose between an Azure SQL Managed Instance, an Azure SQL Database Elastic Pool, or ASQL Server Always on Availability Group. For Statement 1, select vCore. Azure Hybrid benefit for Azure SQL is available through the vCore purchasing model. For Statement 2, select an Azure SQL Database Elastic Pool. Elastic pools provide per-database performance elasticity within shared pool capacity. The key takeaway is use vCore for Azure Hybrid benefit and elastic pools for many databases with non-overlapping demand. Now consider question number 217. Scenario. After migrating an application, administrators must prevent accidental deletion or management plane modification of its production storage account while still allowing the application to read and write blob data. Which control should be applied to the storage account resource? The options are: Choice A, a blob service access policy. Choice B, an Azure resource lock. Choice C, additional Azure RBAC data roles. Choice D, a public container access level change. The required response is option B, an Azure resource lock. The requirement is satisfied because a cannot delete or read-only resource lock protects Azure Resource Manager operations on the storage account without serving as blob data plane authorization. The remaining options are incorrect because A, a service access policy governs delegated data access, not management plane deletion. C, RBAC controls who can act, but does not provide the same explicit lock against accidental resource changes. D, container access level affects anonymous access and weakens security. Resource locks protect management plane resources. Immutability policies protect blob data from modification or deletion. Let us examine question number 218. Begin by examining the scenario. Development teams operate several applications that must consume centrally managed settings and feature flags. Configuration changes should not require rebuilding container images or modifying deployment pipelines. Which Azure service should be recommended? Review each available choice. Option A is Azure App Configuration. Option B is Azure Container Registry. Option C is App Service Deployment Slots. Option D is CI/CD Source Configuration. The best answer is option A, Azure App Configuration. The reasoning is as follows. Azure App Configuration centralizes application settings and feature flags and allows applications to refresh configuration independently of deployments. The incorrect choices fail for the following reasons. B. Container registry stores images, not runtime configuration. C. Deployment slots support release validation and swaps, not centralized cross-application configuration. D. CI/CD automates delivery, but is not a configuration store. Exam tip. Use app configuration for centralized settings and feature flags. Use Key Vault for secrets. Let us examine question number 219. The focus now shifts to high availability. Review the scenario carefully. A public app service workload must run in 2 Azure regions and survive a regional outage. Dedicated single-tenant isolation is not required, and cost must be minimized. Which app service compute architecture should you recommend? Now examine the possible answers. Option A is one app service environment per availability zone. Option B is one app service environment per region. Option C is one multi-tenant app service plan per region. Option D is one app service plan per availability zone. The appropriate choice is option C, one multi-tenant app service plan per region. The key reason is a separate multi-tenant app service plan in each region provides independent regional compute at lower cost than app service environments. Now consider why the remaining options are unsuitable. A. Multiple ASEs per zone are expensive and unnecessary without isolation requirements. B. An ASE per region provides isolation but costs more than required. D. App service plans are regional resources and are not deployed as one plan per availability zone. Remember this distinction for the exam. For regional app service resilience, deploy independent plans and apps in each region and add a global routing service. Evaluate question number 220. Against every requirement. Identify the decisive requirement in this scenario. A multi-tenant application stores each tenant's documents in Azure Storage. Every tenant must have a distinct customer-managed encryption key, while the storage account also uses customer-managed encryption. The data is accessed as objects rather than SMB files. Which storage design should you deploy? Evaluate each option against the stated requirement. Next, option A. Premium Azure files with one account-level key. Next, option B. Block blobs in a GPv2 account with a separate encryption scope for each tenant. Next, option C. ADLS Generation 2 directories protected only by ACLs. Next, option D. Azure files in a GPv2 account with shared keys. In this case, select option B. Block blobs in a GPv2 account with a separate encryption scope for each tenant. Blob encryption scopes can use different customer-managed keys for different tenants within the same storage account, while preserving account-wide Azure storage encryption. A. A single account-level key does not provide tenant-specific keys. C. ACLs control authorization but do not assign a separate encryption key per tenant. D. Shared keys are authentication credentials and do not provide per tenant encryption scopes. Keep this examination point in mind. Use encryption scopes when multiple tenants in one storage account require different encryption keys. Question number 221 highlights an important distinction. We are moving to identity governance. Focus on the following situation. External consultants must request time-limited access to a project group, SaaS application, and SharePoint site through one governed workflow. Requests require manager approval and access must expire automatically. Complete the identity governance recommendation. Statement 1. Use the blank as the governing service. Select from Microsoft Intra ID Governance, Microsoft Intra ID Protection, Microsoft Intra Privileged Identity Management, or Azure Automation. Statement 2. Implement the request workflow by using the blank. Select from Access Packages, Access Reviews, Runbooks, or Sign-in Risk Policies. Statement 1 should be completed with Microsoft Intra ID Governance. Identity governance contains entitlement management capabilities. Statement 2 should be completed with Access Packages. Access Packages provide request, approval, assignment, and expiration workflows. A useful examination rule is this. Use access packages to govern bundled resource access. Use access reviews to periodically recertify existing access. Review question number 222. Carefully. Let us first review the situation. A SaaS web application maintains one Azure SQL database for each customer. The databases have unpredictable, non-overlapping usage peaks and require a managed relational service with a shared cost envelope. Which data storage strategy should you recommend? Review each available choice. Choice A, SQL server on an Azure virtual machine. Choice B, a separate fixed-size DTU database for every customer. Choice C, an Azure SQL database elastic pool. Choice D, a separate provision vCore database for every customer. The best answer is option C, an Azure SQL database elastic pool. This is correct because an elastic pool allows multiple customer databases to share compute resources while preserving database isolation, which is cost-effective for varying usage patterns. The other choices do not satisfy the requirement because A, SQL server on a VM increases patching and platform management. B, fixed-size databases strand capacity when customer peaks do not overlap. D, separate provision databases do not share a common resource pool. The key takeaway is elastic pools are designed for multiple databases with variable and unpredictable demand. Proceed to question number 223. The focus now shifts to global routing. Consider this scenario. A company deploys one fixed instance app service app in North Europe and another in West Europe. A traffic manager profile uses priority routing and endpoint health checks. No app service autoscale rules are configured. For each statement, select yes if the statement is true. Otherwise, select no. Review statement 1. The design provides service continuity if one Azure region becomes unavailable. Review statement 2. The design automatically adds app service workers when request volume increases. Review statement 3. The routing configuration requires a manual DNS change when the primary regional endpoint fails. Statement 1. The answer is yes. Traffic Manager Health Probes can direct clients to the healthy regional endpoint. Statement 2. The answer is no. Traffic Manager controls endpoint selection but does not scale an app service plan. Statement 3. The answer is no. Traffic Manager automatically changes DNS responses based on endpoint health. Global routing and compute autoscaling are independent architecture concerns. The next item is question number 224. Two on-premises databases use server-side cross-database transactions. After migration, the managed database service must preserve that compatibility, use synchronous local replicas, and remain available during an availability zone outage. Complete the database and service tier recommendation. For the first statement, deploy the databases to the blank. Choose between a single Azure SQL database, Azure SQL Managed Instance, or an Azure SQL Database Elastic Pool. For the second statement, use the blank service tier. Choose between hyperscale, business critical, or general purpose. The answer to the first statement is Azure SQL Managed Instance. Managed Instance preserves instance-scoped compatibility needed by the workload. The answer to the second statement is business critical. Business critical is the tier designed for low-latency synchronous replicas and high availability. Exam tip. Use Managed Instance for instance-level SQL compatibility. Choose Business Critical when synchronous replica performance and zone resilience are decisive. Question number 225. Next, we enter the topic of secrets and key design. Review the situation. An app service app uses a system-assigned managed identity. Database credentials must be exposed to the app as environment-style settings without changing application code, and the identity must receive only the minimum key vault permission. Complete the key vault integration design. Review statement 1. Configure the blank. The options for this statement are key vault references in app service application settings, key vault references in app settings.json, key vault references in web.config, or direct key vault SDK calls. Review statement 2. Grant the managed identity the blank. The options for this statement are secrets, get, secrets, list, and get, keys, get, or keys. list, and get. The correct value for Statement 1 is Key Vault References in App Service Application Settings. Application setting references minimize code changes. The correct value for Statement 2 is Secrets. Get. Get is the least privilege needed to retrieve a known secret. Remember this distinction for the exam. For App Service Key Vault References, grant only secret retrieval permission to the selected managed identity. Question number 226. A governance team needs a monthly inventory of Azure Resource Manager create and update operations performed in a subscription. Which data source should the reporting solution use? Option A, Azure Activity Log. Option B, Azure Arc. Option C, Azure Analysis Services. Option D, Azure Monitor Action Groups. The correct answer is Option A, Azure Activity Log. Here is the technical justification. The Azure Activity Log records subscription-level control plane operations, including resource deployments and changes, and can be exported for reporting. The alternatives can be eliminated because B, Azure Arc extends Azure management to external resources, but is not the deployment audit log. C, Analysis Services is a semantic modeling service and is not the source of ARM operations. D, Action Groups deliver notifications and actions. They do not store deployment history. Keep this examination point in mind. Use Activity Log for control plane audit events and resource change reporting. Proceed to question number 227. We are moving to authorization design. Review the situation. 10 network engineers are members of one Microsoft Intra-Security group. All networking resources are contained in subscriptions beneath one management group, and every engineer requires the same network contributor permissions across that scope. What is the minimum number of role assignments required? Review the options. Choice A 1, Choice B 2, Choice C 5, Choice D 10, Choice E 15. The required response is Option A 1. The requirement is satisfied because assigning network contributor once to the security group at the common management group scope allows the permission to inherit to descendant subscriptions and resources. The remaining options are incorrect because B, a second assignment is unnecessary when all resources share the same inherited scope. C, per subscription assignments create avoidable administration. D, per user assignments ignore group-based access. E, 15 assignments exceed the minimum and increase management effort. A useful examination rule is this. Minimize Azure RBAC assignments by using groups and the highest common scope that does not grant excessive access. Now consider question number 228. Scenario. A legacy line of business system will run SQL Server on Azure virtual machines and requires instance-level high availability. The design should avoid duplicating all database storage, use shared storage with production performance, and minimize failover time after one VM fails. Which deployment should you recommend? Available choices. Option A, an always-on availability group with premium disks and a virtual network name. Option B, an always-on failover cluster instance with a standard file share. Option C, an always-on availability group with premium disks and a distributed network name. Option D, an always-on failover cluster instance with a premium file share and a virtual network name. The correct answer is Option D, an always-on failover cluster instance with a premium file share and a virtual network name. The reasoning is as follows. A failover cluster instance provides instance-level protection and uses shared storage, avoiding a full storage copy per replica. Premium file shares provide the performance and availability needed for the shared database files. The incorrect choices fail for the following reasons. A, an availability group duplicates database storage on each replica and protects databases rather than the whole instance. B, a standard file share is not the appropriate performance tier for this production SQL shared storage design. C, a DNN simplifies AG connectivity but still requires duplicated database storage. The key takeaway is use FCI for shared storage instance-level high availability. Use availability groups for database-level replicas and read-scale scenarios. The next item is question number 229. Consider this scenario. Developers may create Azure virtual machines, but deployments must be limited to approved regions and an approved list of VM SKUs. Which governance control should enforce both restrictions? The options are: Choice A, Attribute-Based Access Control. Choice B, Azure Policy. Choice C, Conditional Access. Choice D, Azure RBAC. The appropriate choice is option B, Azure Policy. The key reason is Azure Policy can deny resource deployments whose location or VM SKU does not match the allowed values. Now consider why the remaining options are unsuitable. A. ABAC adds conditions to role assignments, but is not the primary service for enforcing general VM location and SKU compliance. C. Conditional access governs identity sign-in conditions. D. RBAC controls who can deploy resources, not which region or VM size they select. Use RBAC for who can act and Azure Policy for what resource configurations are allowed. You have completed Part 5 of the AZ-305 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.